Hi, my name is Scott Thumlert, and I'm working with the University of Calgary at the Applied Snow and Avalanche Research Group. This short chat will be on how do you stress the snowpack. I'm going to start off with a few videos showing where we did our measurements. This is Bruce snowboarding right now. There's some sensors buried in the snowpack, and we're measuring how much stress Bruce there was putting onto the snowpack. Here's another video with some snowmobiling. Again, you can see the sensors behind me there buried in the snowpack, and we mount them on long sheets and slide them in. And then we simply sled or snowmobile or ski over top of the snowpack and record the values in the snowpack of how much stress there is. So that's where all the numbers that I'm about to show you guys came from. The reason for doing this project is more than 90% of fatalities caused by avalanches result from people triggering the slides themselves. That's a Canadian statistic, but the European stats are very similar. So what that says is that when we go skiing or snowmobiling, especially on slopes, we are influencing the slopes and causing some failures within the snowpack that sometimes is resulting in avalanches, and that's getting us into some problems sometimes. So the first idea, how are we influencing the snowpack? And what we're looking at right here is just something to start off with, and it's just some calculations based on some equations, and it's just for a snowmobile sitting on top of the snowpack. So what we see right away from these, just very simple calculations, is a big bulb of stress immediately downhill or right below the front of the snowmobile here. And it looks like the stress also decreases quite quickly with depth. And so this just gives us a bit of an idea of what the stress underneath us looks like when we go snowmobiling or skiing. Keep in mind this is for a snowmobile just sitting on top. So when a snowmobile or a skier are actually moving, these bulbs are going to change in shape, they're going to change in magnitude, and they're going to be a lot different if you're doing, say, short, more choppy ski turns on skinny skis, or if you're on fatter skis doing really long, big GS type turns. But the idea is that these bulbs are going on in the snowpack below us, and they are always changing. So one of the questions is, well, if there's a weak layer, say down at $1.40 m, is this bulb going to affect this weak layer and cause a fracture? Probably not. It's at $1.40 m, right? Well, what if it's somewhere around 80 centimeters? Now this pink part is touching. Maybe there's enough stress from our skiing or snowmobiling causes a failure in that weak layer, right? Well, what if you add in a nice green, a nice safe crust that effectively bridges that stress out and keeps the stress from hitting that layer? So these are some of the things we're thinking about. The stress in the snowpack matters how and what type of trigger. So if you're snowmobiling or skiing and how you're doing that, but it also depends on what type of snowpack you have. So these are some of the questions and things we're trying to figure out with some of these measurements. Here's the equipment that we used last winter. You can see the capacitive sensors here mounted on the end of big aluminum sheets. And then what we did, we take these big aluminum sheets and simply inserted them into the snowpack. You can see there we dug a snow profile and then inserted the sensors right there into the snowpack. And then we simply, after that, turn the sensors on and ski or snowmobile over top of the snowpack, and those things record numbers. I'm going to show 4 graphs coming up, and they're all very similar, so I'll go slow on the first one and speed up. This is stress on the top axis, so 0, so low stress on this side, and as you move this way, higher stress, more force in the snowpack. And on this side, we're starting with it's depth. So starting at 30 centimeters, 0, the snowpack surface will be up here, and we're moving down into the snowpack. All the way down at the bottom here is about 1.20 m into the pack. What you're looking at are box plots. So the boxes represent the middle 50% of the numbers. So at 40 centimeters down in the snowpack, why there's a lot of measurements here is that we went out about 11 or 12 days last winter, and each day we put the sensors in at 40 centimeters. So this box plot represents a bit of the variation in the days. So maybe in the early part of the season when the snowpack's a lot softer, we're getting more stress into the snowpack, and maybe later on in the year when the snowpack's a little more settled, we're getting less stress because it's dissipating further and quicker. So the white box plot is for snowmobiles, and the gray box plot is for skiers. And this little line here in the middle is the middle value of the box. And then these big lines, curvy lines that are on there are fits to the data. So that is the line that, say, best represents all of the data. And so looking at this plot as a whole, the biggest takeaway point from it is that we see that the fit for the snowmobiles up here is higher or more stress than the skiers. So this plot at the end of the day just says snowmobiles are adding more stress to the snowpack compared to skiers. So moving on, the next graph is going to be the exact same thing, except on the left it's going to be effective depth. So effective depth is simply the distance between the bottom of the snowmobile and the sensor, whereas depth was from the top of the snowpack to the sensor. So if we had the snowmobile penetrating the surface, say 30 centimeters, well, you'd subtract that 30 centimeters from the depth of the sensor at 80, and you get this effective depth of 50. So effective depth is the distance between the sensor and either the skis or the track on the snowmobile, rather than the surface, which would be a little higher. So again, same plot, stress on the top, you're looking at box plots, and effective depth on the left-hand side. Again, the white are the snowmobiles and the gray are the skiers. And the take-home point, again, looking at this graph, these curvy lines are the fits, and they almost exactly overlap each other. So when you remove penetration from the equation, or from the last plot, we see that the stress in the snowpack for skiers and snowmobiles is almost the same. So that says, well, penetration, or the difference in penetration between sleds and skiers, is maybe the main reason why sleds are adding more stress to the snowpack compared to skiers. So a plot, just to look at that, well, what's the penetration difference between skiers and snowmobiles? And if we look at snowmobiles here, it's 50 centimeters is this middle line, and skiers over here is about 25. So from these measurements, the sleds were penetrating the snowpack twice as much as skiers. So this just tells us, okay, if we have more penetration, you have more stress, and this difference in penetration between skiers and snowmobiles is the reason why sleds are adding more stress to the snowpack. So we started thinking, well, okay, if this penetration is the big difference, well, how does that affect some stability tests? And we started thinking, well, how does the stress in the snowpack when we go skiing, how does that compare to what we do when we stress the snowpack in our stability tests? So we just did a lot of little experiments out there, taking some measurements in compression tests and extended tests and a few other ones. And one of the things we started thinking about when we were talking about this penetration and penetration being such a big part of it, we decided to change the compression tests a little around to change it around a little bit to maybe just to see what would happen. So what we started to do is, if you imagine this red box over here as the depth that the sled is penetrating, we measure that, say it was about 30 centimeters, and then we go over to our compression test, take off 30 centimeters of snow, and just basically end up with a shorter column. And then we'd stick the sensors in and tap on the top and do some measurements. And on the same day, we would start off with the original test, compression test, put the sensors in and do some taps. So we're just getting comparisons each day to see how it all related. And this is the last graph, very similar in that we still have stress on the top here and depth into the snowpack on the right, on the left. We're only showing two depths, 60 centimeters and 80 centimeters. Snowmobiles, again, are this big white box, and the red is the stress from the hard taps in the compression test, and the green is the hard taps in this test where we remove the top of the column that was equal to the skier or snowmobile penetration. So what we see right away that's kind of interesting is that if you look at this middle value on the snowmobiles, it's higher than the middle value on your taps, hard taps in the compression test. So sometimes when you're going snowmobiling in particular, you're adding more stress to the snowpack than you are when you're actually doing your test. So, and then looking at this test where we took the penetration off, you know, it's higher, so you are adding more stress compared to the snowmobile. Anyway, so the idea here is that if snowmobiles are adding more stress to the snow cover, maybe there is something that we can develop or do, you know, that a snowmobile is better off for a snowmobile when they're trying to assess the slope stability. So the big question is, is there a better test or a modification that snowmobilers could do in order to get a better idea of slope stability? So the conclusions: snowmobiles are adding 2 to 3 times more stress to the snowpack compared to skiers. More penetration is more stress, and the difference in penetration appears to be why the sleds are adding more stress. And are there different tests or changes that we can do for snowmobiles, or maybe it's not relevant, but you know, it's bringing up more questions. I'd like to thank these people who sponsor the research we do at the university here. And in particular with this study, I'd like to thank the guides at Mike Wigley's for helping out logistically. They really are amazing getting us out into the snowpack and into the mountains every day. And in particular, Mike Weeder and Michael Shinkarik were out there with me, you know, every day digging a lot of snow profiles and standing in really cold snow for a long time. So I'd like to thank them. Thanks for listening.